Um, I couldn't believe yesterday when I was out, I heard that Mir, Adnan and Iyad, all three of you were in at 9 o'clock.
And Michelle will not.
And yes, the two of us weren't and everyone else was. I just thought it was funny, thinking, so close to having all five of us in the same room again.
I know, right? It seems like it will never happen. Except for
I think the last time it happened was when Mir came in that one afternoon. Okay. Do you want to give me the info for it? So what's the story in it?
Yeah.
It's a ladder against a wall, right?
It's a trapdoor.
Oh, it's a trapdoor one. That's right. Sorry, I was thinking of the other one. So there's a trapdoor. Okay, so it looks something like this.
Yeah.
Yeah. Okay.
0.85 meters.
The full length.
Yes.
Cool.
With a 9 thickness.
Yeah. Okay.
Attached to a hinge at point O.
Yeah, which is here.
Yes.
Okay.
Held in a horizontal position by applying force Q.
And the direction of Q is probably this way, to the left. Oh yeah, okay. Q. Oh yeah, so there's like they're saying that there's like a string here,
Yeah.
or something which Q, and there's a reaction force here of the hinge or whatever,
Mm-hmm.
which is like P, and then of course there's a weight here.
Yes. The force Q is 35.6 newtons.
That's the weight.
No.
Oh, Q, sorry, is 36.5.
5.6.
Okay.
In a direction BC, so that's BC.
That's this one here, yeah.
Acting at an angle of 40.
Oh, you know this angle here, 40.
To the trapdoor, yes.
Yeah.
The center of the gravity trapdoor is located 0.39 meters from O.
So this is 0.39
Yeah.
meters, which is 46 then for this one, I think.
And we're not given the weight.
Oh, that's something to find, is it?
Mm-hmm.
So I'll call it W.
Yep.
This is all the info?
Yes.
Cool. What's the first part? A1?
Determine the mass of the trapdoor.
Okay. So I'm going to go with the three-force theorem here because this seems exactly suited for the three-force theorem, which states that all the forces meet at one common point, which I'll write here. So this is 90. So if that's 40, then you know this one is 50. That's 90 as well. We don't know this. I'm going to call it theta. And we don't know this. Although as soon as we know theta, we can know it. What else do we know? We know this length and this angle. So we can know this side. Because I could say tan 40, let me call this, I don't know, H. Tan 40 equals H over, sorry, not tan, totally wrong. Should have said something else. I should say sine 40 equals H over, oh my goodness, I'm totally off today. I was right the first time. Tan 40 equals H, over 0.46. So I know the H. Now I'll just leave it like this for the moment, because I know the H, and then if I look at this one, I can say tan theta equals H over 0.39, but I know the H now, so tan theta is 0.46 tan 40 over 0.39. So I feel like getting the theta will be a good thing, which will be tan inverse that. Now I didn't open my calculator, so can you tan inverse that fraction there, please, while the calculator opens? Yeah, that whole fraction inside it. Seems reasonable. 46.99. So we'll say 47. Okay. Now, Do we know what P is? Did they tell us P?
No.
They don't. Okay, so I can resolve this into P cos theta and P sin theta. And I know that P cos theta must equal this here,
Yeah.
which is 35.6 cos 40. So then P is that divided by cos 47. So if you don't mind, please, I'll get the P. Okay, so that's got to be 40 newtons. So finally, this vertical component plus this vertical component should equal the weight. So I can say weight will equal P sine theta plus Q sine theta. Now weight is actually equal to mg. And it's the m that they want.
Yes.
So if I divide by this answer by g, I am finished. Yep, all over 9.81.
Is it 40 or 46?
40.
5.31.
5.31.
Should I check?
Might as well. We could have typed something in wrong. My handwriting's a bit messy. One of my 40s could have been a 46 or something.
But okay, I get the idea. It's fine.
Yeah.
Yeah.
What's the next part?
Determine the magnitude and direction.
Now you see, this is the beautiful thing about doing it using the three-fourths theorem. We've already done it. So we've actually done part 2 as well. What's part 3?
That's it. Now it's an object with mass 10.
Oh, this is part C.
Yeah, we finished 1 and 2 for this question.
For A.
Yeah.
So what happened to B?
This is B. The first.
Oh, so it's definition or something.
Like,
Yeah, so this is B. Okay, so how many marks for B1 and 2?
9.
So 9 marks for this then. Okay. This is probably not the way to do it in the marking scheme. They did it a longer way. They use clockwise and anti-clockwise, I'd say.
Yeah. Taking moments about
Yeah.
Yeah.
Okay. Let's continue. What's the C part then?
An object A of mass 10.85 kilograms is at rest on a smooth ice rink. A horizontal force of 125 newtons acts on the object for 0.2 seconds, setting the object in a linear motion. Determine the velocity.
Okay, so
After the force.
great. V equals U plus AT, and it starts at rest, so it's equal to AT. And we know the T. So it all looks good except we don't know the A. But from using Newton, we can say A is F over M, which are both things we know. So it's 0.2 times, 125 over 10.85. What's this, like a 2 mark or 3 mark question? 2 marks, yeah. So, 24, around about 2.8 or something? 2.3, okay. 2.3 meters per second. Is that the end of question 1?
Part 2.
Oh, there's a second part to this?
Yeah, there's a lot actually.
Oh, okay.
Object A is then in collision with object B of mass 15.62. Initially moving the opposite direction at a speed of 3.670 meters per second. After the collision, object B continues to move in the same direction at a speed of 1.210.
1.210.
When they say the same direction,
To the left in my picture still.
okay.
So basically, you know that this is still going left, so it's a negative still.
Yeah.
So, and what did it say? What happened to A?
Determine the new speed and.
That's what they want. Yeah. So, what was the mass there? I wrote it down, but it's messy. 10.85. M1 U1 plus M2 U2 equals M1 V1, which is what we want, plus M2 V2. .21 is the V2. So V1 would equal 10.85 times 2.3 minus 15.62 times 3.67 plus 15.62 times 1.21 all over 10.85. Minus 1.24. Yes, it has to be minus as well as B. If B is minus after the collision, so should A be. Yeah, so that seems reasonable.
Determine the total change in kinetic energy.
Okay, yeah. So the loss in kinetic energy will be the kinetic energy afterwards, which is a half mv squared, which is 1.24 squared, plus a half m, which is 15.62, v2 squared, which is 1.21 squared, then minus a half m u1 squared, which is 2.3 squared, and minus a half m 15.62, and then 3.67 squared.
Minus 114.
Yeah, I'm sorry, I wrote it backwards. I should have written the after first. No, I mean the before first, because the four is bigger. So what number did you get?
114.
Okay, so that means the loss in kinetic energy is 114 joules then.
Accounts for this change in kinetic energy.
Okay.
You say like what turn to heat and that kind of stuff.
Yeah. 114 joules, 2 marks,
Yeah.
turned into heat and sound, I'd say. Is that the end of number 1?
That's B1.
Okay, so here's our choices. Now, it's totally up to you because it's really whatever you want to see. So we can do an A, we can do a B, we can do a particular topic or a particular exam. Really, whatever you think would best help you.
Yeah, we can just finish this paper.
We'll finish this paper?
Yeah.
Okay. So what topic is B2 then?
State universal law of gravitation.
So it sounds like fields then. Right, this is part A. How many marks is that?
2.
Okay, so
Explaining all symbols used.
yeah, so they want you to give you the formula and then explain everything here. So G is a gravitational constant, M1 is the mass of object 1, M2 is the mass of object 2, or is the distance between their center of masses, and F is the attractive force, gravitational force between them. So how many marks did you say for that? 2? Yeah, okay. What's next now?
Planet Mars can be considered to move around the Sun in a circular orbit of radius 2.28 10 to the 8.
This seems very familiar. When we do one like this, are they looking for the mass of the Sun in the question?
No,
No, they're not.
tangential velocity.
Ah, okay, this is a different one. Okay, so let's draw this here. So what do they give you here? The radius?
Yeah, 2.28 10 to the 8 kilometers.
2.28 times 10 to the 8 kilometers. Okay.
And the mass of the Sun is 1.989 10 to the
1.989 10 to the 13?
30.
13. Yeah.
Determine the tangential velocity.
Right. So I think you have to go with force F, circular force is the same as the force due to gravity. In other words, it's moving in a circle. So the circular motion force is caused by the gravity force. So you can say mv squared over r equals gmm over r squared. We don't need to know the mass of the planet, which is good because we don't. I can cancel the or with one of these. So I'm actually just left with calculating this 6.67 times 10 to the minus 11 times 1.989 times 10 to the 30 all over 2.28 times 10 to the 8 times 10 to the 3.
Times 10 to the 3.
Yeah, it's changed it into meters from kilometers.
Oh, yeah. 24 or 1 to 1.
Yeah.
0.97.
So 24 kilometers per second. Great, okay.
Okay. Determine the time in Earth days for Mars to complete one orbit.
Okay, well, T is 2 pi over omega. And we can say m omega squared or is equal to the force, and m omega squared or is also equal to m. Oh, what am I doing? Sorry, I just realized another formula I can use. V equals omega or.
Yeah.
So we can say omega is v over or. So we can change it into 2 pi over v over or, which is good because all those things are things we know. It is 2 pi or over v, which is 2 times 3.1415 times 2.28 times 10 to the 8 times 10 to the 3, all over 24 times 10 to the 3. Now, whatever answer you get, it'll be big,
Yeah.
because it's in seconds. Divide it by 3,600 to make it hours, and then divide it again by 24 to make it days.
690.
6.
190 days.
Okay, so Earth days.
Part 3.
Oh, okay.
The Martian moon photo takes 7 hours, 39.2 minutes to complete one orbit of the planet. If the radius of this orbit is 9,400 kilometers, determine the mass of Mars.
Cool. So this is Kepler's law, which I always forget. You have GMM over R squared equals M omega squared R. So you cancel the M's, you bring down the R, make that 3. You square root here, and then omega is equal to 2 pi over t. So you can say t is, if I bring that up, 2 pi root r cubed over gm, or it's usually written as t squared equals 4 pi squared r cubed over gm. But this, I rearranged this because I don't really want the t, I want the m. So I'll say t squared equals 4 pi squared r cubed over gm. Yeah, so I actually have here m is equal to g 4 pi squared g
R cubed over gt squared.
over gt squared. R cubed over gt squared, which would be here 4 pi squared 9400 times 10 to the 3 cubed over 6.67 times 10 to the minus 11. Now we have to be careful here because we need to put this into seconds. So 7 times 3600 makes the hours into seconds, and then plus 39.2 times 60 makes the minutes into seconds. That's a multiply there, and that's a multiply there, and that's a plus. And this is to change the hours, and this is to change the minutes. Yeah, I guess that seems, yeah, I think that's right, because I think the Earth is like 10 to the 23 as well, or 24 or something, so that seems reasonable again. Is there more to this?
Yes.
Yeah.
Determine the gravitational field strength
Okay.
surface of Mars if its radius is 3396.
Okay, so that form is gm over r squared, which is 6.67 times 10 to the minus 11 times 6.47 times 10 to the 23. And what did you say the radius was?
3396.
3396 kilometers, yeah?
Yeah.
It should be similar to Earth's value.
Um, 3.74.
Yeah. Newtons per kilogram. Yeah, yeah. And I'm sure it continues, right? Or
C.
Hertz. C.
Yeah. A spacecraft attempting a landing on Mars, hovering in stationary position above the planet's surface. It released a probe, initially at rest, from a height of 100 meters above the surface, so that it falls in a vertical direction. Determine the velocity as it hits V.
So it starts at rest, the acceleration is downwards and the distance travelled is downwards, although you could make them all positive if you wanted to. Yeah, v squared is the one, equals u squared plus 2a s. So what's nice here is we and square root of it. It's square root of 2 times 374, which is square root of 600, 748 or something, whatever that is.
Anyway, 27.3.
That seems right. 27.3 years. Now there's actually technically two answers here, plus or minus, so since it's heading down we'll take the minus for V, and if they're looking for the speed, we don't care about the sign, so the speed is 27.3 meters per second. How many marks for that? 2, 3? 2. Yeah, 2. More?
Yes.
Oh, is this where the probe hits the sand now?
The probe of mass 5.3 to penetrate 0.265 into the surface.
Okay, the mass is 5.32 kilograms, and it penetrates a distance of
0.265.
Cool.
Determine the average retarding force.
Okay. You knew the speed here because that's what they got you to do previously. 27.3 meters per second. So we'll go with the total force on this as it hits the sand is the weight minus this retardant force, which I'll call R.
Yeah.
So when it's going to the ground, there's two forces acting on it, a downward weight and then an upward retardant force, and R will be bigger than W. So I'm expecting this F to be a negative in total, positive. What am I saying?
R will be bigger than W.
Yeah, the R is definitely bigger than the W, so this should be, the F will be a negative, which maybe I'll switch it around. Total force is R minus W. Now I'll keep it that way, but just be careful with my sign. So to be very clear here, down is positive, up is negative, so that's why this is a positive and this is a negative here. Okay. So they want the R. So the R is equal to F minus W. The F is the total force, which we can use as MA. But we don't use this one because we don't know the A. I know it seems like we know the A, but that's the A when it's fallen, not when it's in the sand. So we can't use this one. But we can use Newton's other version of the formula, which is F is delta P over delta T minus the weight, which is mg. And delta P is mv minus mu over delta T minus mg. Now what's nice here is that there's an m in everything, so I can take that out. And I'm left with v minus u over t minus g. And that's nice as well, because the m is something we're given. It's 5.32. The v is something we know, it's 0. The u is 27.3. The t we don't know. So I think I should work out the t before going ahead. I think I have enough info. U is minus 27.3, which means I really have two minuses here then. V is 0. A, I don't know. T, I don't know. Okay, so the situation is, doing it this way, I've not saved any work. If I use this first formula, I still need to work out what the A is because I don't know it. But if I use this other version of the formula instead of this, I still have to work out the T because I don't know it. So, both situations, it's the same deal. I haven't, in fact, if anything, I've made it slightly longer by doing it this way. Because I still have to, I cannot avoid doing UVATS. It's the only difference is this time I'm looking for T. So let's get the T. S equals U And you know what? I think I have made it harder by doing it this way. So I'm going to backtrack and use the other formula that I originally had here. So let me just scratch that out. Right, so it's equal to MA minus MG, which is equal to MA minus G. So I just need to work out the A now. UVATS. U is minus 27.3, B is 0, A we don't know, T we don't know, S is minus 0.265. And I can say V squared equals U squared plus 2A S. So I get A is 27.3 squared over 2 times 0.265. $98.75. Now be very careful here. The G is not 9.81. Yeah, it's 3.71, something like that. 3.74, yeah. $505.45 newtons. Now, what did they say in the Martin scheme was the answer? I know why they said that. Could you type in EAD on your calculator 98.75 times 5.32? What do you get?
525.33.
That's not the answer they got.
No.
You know what? I think I've made a sign mistake. No, have I?
They got the A minus 27.37 squared over 2 times 0.265. But they used the minus.
I feel like I made a sign mistake.
Minus 27.37 squared over 2 times 0.265. Okay.
If you add these two together and multiply by 5.32, do we get the same answer?
Times 5.32. It's minus 7519, which is close to what they got here.
So I possibly made a sign mistake.
They didn't minus G in the. They just said F equals MA. They got the A from UVATS
Yeah.
and then multiplied. They got the A, yeah, and they multiplied that by M. That's it. And then they said hence the average return equals to 7.52 times. Or use half mv squared equals Fx. What is that? So F equals half mv squared over X. And
Yeah,
now X is
the distance.
The distance. What is that formula though?
There's another formula for Fs. Doesn't work.
Oh yeah. Okay.
So the kinetic energy equals the work, and that works as well. And this should work as well. I made some stupid sign mistake.
They just didn't do MA minus MG, that's all. That's the only difference.
Yeah, you don't have to do it this way. You could use energy to get it, which I kind of like. Actually, it's a nicer way to do it. It's shorter. But what on earth is my sign mistake? There's a sign mistake somewhere there. I found my sign mistake. right here. This acceleration is downwards, so the answer is a minus, which means that there is a minus, which then changes that to the right answer then. Minus, what did we get now? 98.75 plus 3.74 times. So what was their final answer?
7520.
Oh, that's way off then. Oh, now, let's do it the way using energy to see if I get the same answer. So another way to think about it, just before it impacts, it has kinetic energy, and then as it's buried into the ground, there's a force acting up to slow it down, and the force that's acting up to slow it down, basically the amount of work this force does will equal the kinetic energy. So force times distance here will equal the kinetic energy. But I feel like I know what mistakes they're making in the book, because did they use MGH there in this approach as well?
No.
See, I think in both cases they're forgetting about the force of gravity. So like in this method here, if we take this as the ground level, I know it's not really the ground level, but in fact we can put the ground level anywhere. This has kinetic and potential. So I'm willing to bet that if I include potential here, because I'm including gravity, I'll get the same answer that I get here. And then if I delete potential, I'll get their answer. Let's see what happens. Okay, so do we know the force acting up? No, of course we're not. That's what we're looking for. So the force will equal kinetic plus potential over S. Yeah. So that would be a half M, what's that, 5.32? And the V was something like, what was it? I had it here a second ago. It was 27.3 plus M, which is 5.32, G, which is 3.74, and H is 0.265. All over 0.265. Force?
0.9, yeah.
How much?
7,500.
Woo! Something went wrong there, I'm sure of it. The decimal point was missed, perhaps?
5.32.
A half times 5.32 plus 27.3. Oops. Okay, sorry.
No, 29.9.
No.
No.
Different answer.
Did you square the 27.3?
Do you know what? I didn't, and that was terrible of me.
Yeah.
Whoa!
Which is close to their answer. Their answer is like 20. 7520. This is 7500. So it's kind of close.
So then that means I totally did something much more than a sign mistake here when I did it this way. Oh, okay, so The reason that my answer is close but not exactly the same is I feel like this amount of potential energy, because the height is so small, doesn't actually change the answer much. And if you delete that out from the calculator, we'll probably get the exact answer. Not quite. Yeah, but you know what? I only have one decimal place here. This is bad of me. But why on earth did I go so wrong here? The A. Let's double check that A. I got a different answer for A. I got 1,406 when I typed this in. Do you want to double check that there? Maybe
14.
Yeah, instead of 98.75.
Yeah.
Yeah. Okay. Times 5.32. Ta-da!
Yeah.
Okay. So that was it then. So we get the same answer this way as well. All cool and groovy. Right, what's next then? Oh, that's the end of B2?
Yeah.
Super. Waves. Alright. I desperately need a cup of coffee because my lips are so dry from being so sick. We'll continue with waves, and then what's after that? Graph, a circuit, electricity question. And then after that? Atoms? Sounds like atoms.
Yeah.
Nice. Alright. Let's stop the video here.